Good morning everybody. Today we will start a lecture on water treatment. Previously you have seen two-phase separator, three-phase separator, gun barrel, heater treater, electrostatic separation system, gravity separating system, horizontal separator, vertical separator. Now we separated oil and we reduced BSW, sedimentation water content, up to 0.5%. Now what oil is sold to your refineries. Okay, for example, ONGC will produce and they will be sold to Reliance refinery maybe. Okay, then you got water, because any wellbore, whenever you are producing oil or gas, maximum amount of fluid they will be producing water actually, because water is available. Okay, so that water you cannot dispose anywhere randomly. Okay, so water disposal one issue. Okay, so before disposing you have to reduce hydrocarbon content. Okay, so if you are not reducing hydrocarbon content, what will happen? You have aquifer zone or the surface area, like say trees will be there, your drinking water zone will be there. If you are disposing somewhere, then those trees will not be surviving, your environmental pollution will be there. So you have to remove hydrocarbon content as much as possible, then you can dispose. Now hydrocarbon, one way is that you can create one dike, maybe you can allow evaporation and you can reduce water content. Okay, that way you can. Another way is that you drill a hole, you put that whatever produced water is there, you put inside wellbore and you dispose that way. But in offshore application, there are some difficulties are there. So first we have to understand how much what oil content or HC, hydrocarbon content, will be there in water before disposing. What are the regulations? And if you are designing certain mechanical treatment equipment, so what is the sizing? Okay, what is the basic equation, what are the fundamental theories are there, we will discuss in this lecture. Okay, so previous lecture we have discussed gun barrel, right? Gun barrel, vertical or horizontal separator, Okay, so basically we got gas, we got oil, we got water. Okay, now gas we did not separate yet. We got gas, but gas will have several other constituents. So we will discuss later some other lecture. Okay, weeks, different weeks. Oil, already we separated almost all BSW, right? So normally we try to maintain 0.5% BSW. Okay, so we removed salt, we removed small water droplet. Okay, so then we try to maintain this one. Then you can send after gun barrel, you can store this oil in your stock tank or you can send to your customer. Now water, whatever you are getting, so that one you have to separate properly. I mean, oil particle you have to remove, sand particle if it is there, anyway it can be disposed along with water maybe, or maybe you have to separate sand separately and handle sand and water and oil, because it will be having economic value, so oil you can use again. Sometime this water separation system, some gas also will be coming out, so the gas also you can use. Okay. So governing regulatory bodies specify hydrocarbon content. So normally 15 to 50 milligram per liter. Okay, so this will be the range. Okay, within this range, government body will say, okay, you have to maintain within this range or less than this one, that's fine. Onshore, water must be disposed, injected into acceptable disposal formation or disposed by evaporation. Okay, so maybe you can put on hole, inject it or evaporate it, so that it will not be spreading everywhere. Okay, reduce hydrocarbon content below the limit from water obtained from free water knockout or oil treaters. Okay, free water knockout, it will have lots of oil content. Even water treating equipment, you have separated small particle of oil, right, and water is separated, then that water will contain some amount of oil. Okay, that you have to remove that one also. Okay, so produce water treatment equipment. So this picture, this table I have taken from Arnold and Morris book. Arnold and Morris, surface production operation book, volume 1. volume 1 chapter 7. Okay. Again you have to see edition, whether a new edition came up and number of chapter changed, so that I don't know, but this is one volume, volume 1 chapter 7. Okay, whatever I am following the book. So there are several ways you can remove oil particle from water. One is gravity separation method, and the plate coalescer, enhanced coalescer, gas flotation, enhanced gas separation, and filtration. So there are several techniques are there. So one separator system can use many of these, mix of these, maybe one or multiple. Okay. So gravity separation is because of gravitational gravity difference of oil and water, the fluid oil particle will be floating slowly going up. Okay. So schema tank or vessel, the approximate minimum droplet size 100 to 150 microns or micrometer. Okay. Disposal pipe. So I'll discuss all these equipments later. Okay, so just you can remember at this moment, okay, if these equipments are there, the particle size will be like 100 to 150 micrometer or microns. Plate coalescer, parallel plate interceptor 30 to 50, corrugated plate, cross flow separator, mixed flow separator. So this is plate type things are there. Later we'll discuss. If you are using enhanced coalescer, precipitation, filtration, and free flow turbulent coalescer, so several types of here also enhanced coalescence system. There are particle size will be 10 to 15, and if you go further separation, then like gas flotation device you can create, hydraulic disperse medium you can create, hydrocyclone you can create, multimedia filtering you can create. So you can separate much smaller particle also. Okay, so this particle separation will be based on your regulator's instruction. Okay, they will say will not accept more than this much of hydrocarbon. So you have to confirm that one, because if you are production engineer, so it is your responsibility to confirm. Okay, otherwise the buyers will not buy, so that will be another issue. Typical produced water treatment system, produced water treatment system. Okay, a typical. Okay, so I'll draw one diagram. So some primary treater is there, primary treater. Okay, from there secondary treater. So many types of treater will be there. So there water you are getting, so you can discharge. Okay, secondary treater. So many types of treater will be there, 1, 2, 3 stages. So they are saying primary treater, secondary treater. Okay, so from there whatever oil you are getting, small amount of oil you will get. So that one again you have to separate, right? So that one you are sending to oil recovery tank. So from water you are getting certain amount of oil, so that oil will also contain some water. Okay, so that you have to remove that water from oil, then again you can use that water, the oil, right? So oil recovery tank. Okay, then oil recovery tank, again you are pumping this one to production separation or oil treater. Production separator or oil treater. Okay, whatever oil you got, you have to separate again. So you are putting that water into another separator. Okay, using one pump, because that other separator will have higher pressure. So you have to increase pressure. Then you put into that high pressure separator. Again, it will be regular process. Okay, so it will be like cyclic thing. Then secondary treater here coming. Then some tank, some oil will go there, and if water is coming, water will be drained, water discharge. Okay, so open drain. So the open drain, closed drain, different types of drain will be there. We will discuss later. Okay. So if you have closed drain, then from there pressure vessel, closed drains will be higher pressure. So pressure vessel, through pressure vessel you are adding that fluid here, and you are sending to oil recovery tank. Oil recovery tank is separating your oil and sending to previous separator, so that water particle can be removed. Okay, and whatever water is there, you can separate separately. Okay, this will be roughly one water separation system diagram. Okay, two separation system from here they are coming. Okay, offshore production water can be piped directly on board after treating, or it can rotate through a disposal pile or skim tank. Okay, later we will discuss what is skim tank or disposal pile. Deck drains must be treated for removal of free oil. Okay, so free oil, extra oil particle is there, so that one you have to remove. This normally done in a skim vessel called sump tank. Okay, so this skim vessel is called sump tank. So whatever oil is there, you have to remove. So in sump tank is done. So water from sump tank is either combined with produced water or routed separately for disposal on board. Okay, so you have lots of small particle of oil, you have to separate. So the basic theory is same actually. Oil particle will be moving up because of density difference. So theory Vt, terminal velocity, we start from there, 1.78. You should remember this one, 10 power minus 6. Almost all chapters contain the same basic formula. Okay, del Sg, specific gravity difference, particle diameter square, and mu viscosity. Okay, this is the basic formula you are using. Now here in water treating system, you use same Vt, but dm mu changed actually. In water case, in previous chapter, where you separated oil particle. So oil particle means dm was oil diameter. In previous case, you separated water particle from oil. Okay, so in that case, previous chapter it was water particle diameter. Now presently we will be using as a oil particle diameter, droplet. Okay, and what will be the viscosity? Viscosity will be water. Okay, but if you see previous chapter, it will be just opposite. Okay, because oil was continuous phase in previous chapter, but here water is continuous phase. Water continuous, oil particle dispersed. Okay, so mu actually continuous phase. Okay, oil droplet size is dispersed phase. Dispersed phase particle diameter. Okay, so you should not get confused when you are putting the values. Maybe in one problem I can create confusion, I can give both values. So you have to select the proper one. Okay, if you say wrong viscosity, wrong dm, then your calculation will be completely wrong. Okay, so you should remember this one. And dispersion. Okay, so they have given one d max formula, dispersion formula 432. So there is no derive here, they have given just empirical type formula. Tr del P 215 2 divided by 5 sigma rho W 3 divided by 5. Okay, this is power, and this is micrometer, and Tr retention time. I am using common symbol, the book also uses same symbol actually, retention time, and del P is pressure difference. Okay, and normally we are using PSI, field unit we are using, and retention time in minute. And what are the terms? Sigma is there. Sigma is surface tension. Actually, it is oil surface tension. Okay, dyne per cm. So surface tension unit also you should remember. Okay, rho W. So if I do not give surface tension unit, you should remember actually this is standard unit, right? Rho equals density, gram per centimeter cube. Okay. Now del P large, then particle diameter will be small. You can see the formula. Okay, so just inversely proportional. If a higher pressure drop is happening, the smaller particle diameter will be producing. So let's say one pipe is here. and oil and water mixture going on, flowing through this pipe, and I have one choke or valve. Okay, so choke or valve, lots of pressure drop will be happening, del P. So large pressure drop happening means particle will be broken, quickly broken. So quickly broken means particle size will be smaller. Okay, so large particle drop, pressure drop is there. So in that case, particle diameter will be smaller. Okay, sigma, surface tension. If surface tension is higher, then particle diameter will be higher. So it will be particle will not try to break actually. Okay, and rho w density. If density is higher, then d max will be lower. Okay, so this I can give some problem like this. How del P, sigma, rho w, tr affecting your particle diameter. So based on this formula, actually you can write answer. Fine. So del P large occurs small distance at choke, valves, or so dmx will be smaller. Okay. Dispersion process theoretically is not instantaneous. Okay, but for calculation purpose we will assume this is instantaneous. Quickly it is happening. So in this case, I can create some problem also. I can give some value and I can ask, okay, what is the possible value of dmax? Okay, so you can calculate roughly. Okay, if I give exact data, then you can get exact value also. Coalescence. Okay, so you have seen VT formula. If two particles are colliding each other, then particle settlement rate will be quicker, or oil particle will be quickly settling. So your retention time will be lower. Okay, so you have low. If you want to know retention time (TR), then your particle size should be bigger. So it will be settling quickly. If the droplet pair exposed to turbulent and fluctuation pressure, so in that case particle will be smaller size. So coalescing will be difficult. Okay, so flotation. In previous chapter, we have seen like if your gas particle is there, so oil droplet, water droplet from oil, separation will be difficult. If gas particle is there, they will not allow to collide each other. They will not allow to make bigger particle. But here, if you have gas particle, so gas particle around the oil droplet, it will try to help to float actually. Okay, so the process of flotation improves separation. So if gas particle is there, it will be improving separation. Okay, so gas assist oil particle separating assist in oil droplet separation. Okay, the flotation process reduce vessel TR. If we are doing, if you have some amount of gas, so it will assist. So it will reduce retention time. So separator also can be smaller size, or retention time can be smaller. Okay.